A very warm good afternoon to everyone and welcome back to your study channel Unacademy. Let's crack your exam and let's achieve our goals together in this year 2021. So I hope you are preparing well for your GATE and ESE exam, and these lectures specially are designed for your preparation of GATE and ESE and specially targeting on GATE because you have your GATE exam in the next month itself. So just keep practicing, keep learning, keep focused on your preparation, and yes, you are sure to achieve whatever you want. Okay, so let's start our lecture today. Before starting, just let me tell you how you can access the Unacademy learning app and the free special classes specially designed for you all, so that आपको benefit मिले Unacademy के top educators से पढ़ने का. You have the top educators, the best educators on Unacademy teaching you from their respective fields. So nothing you have to do is just you have to download the Unacademy learning app, and after downloading the learning app you can go for your subscription, as well as you can access to those free special classes specially for you. Okay, so there's a live class section where you have these special classes. तो आप GATE और ES के अंदर you can learn through those live classes, and top educators from their respective fields are taking those live classes for you and teaching you, so you have the chance to be guided by the best mentors of all the fields. Okay, so just do not miss this chance. Go download your Unacademy learning app, and when you go for your subscription in Plus and Iconic, in Plus you have a lot of advantages. ठीक है, special classes आपके लिए हो रही हैं, live classes हैं, but in Plus and Iconic, in Plus you will see you have those structured course and PDFs for you. You have live tests and quizzes every day, and you have those one-to-one interaction with your educators. And the best thing is you will have a complete package with all the advantages which you cannot get anywhere, but yes, you are getting it here on Unacademy. So it is just a revolutionary change for you all. Do not miss that chance. In Iconic you get a personalized coach, okay, and the study material is given to you for complete preparation, a complete study planner as per your need, and your level of preparation is given to you. It's just a I could say a best opportunity which you are getting just right at your home. You just need your mobile phones or your laptop and the Unacademy app, which you can access anywhere, anytime. So you can get your plans, and the rates will reduce when you apply my code, this ARO10. This is a code for you to get advantage by reducing the rate to 10%. Okay, so your monthly subscription cost will be reduced by 10%, and you will have the advantages with very minimum cost. If you could see this per monthly cost of this plan, so it's very minimum. Okay, and with all these added advantage, definitely this is worth paying, because a complete package you are not going to get anywhere other than this platform, that's Unacademy. So just do not miss it. Try to focus on your preparation in a complete manner, and ऐसा ना हो कि हम अच्छे से prepare कर रहे हैं, but at the end due to some mistakes and some lacking we are just missing out. So that should not happen. So just take advantage of this plans in Iconic as well as your Plus subscription. Now especially the students in first, second and third year, you guys know you have an ample amount of time at this point of time, so you can have a very focused and well planned study. So just do not miss anything just because of lack of guidance or lack of material that's made available to you on Unacademy. So just take advantage of the same. Okay, so that was about telling you about the same, and you can definitely use the code ARO10 to get access to those free live classes specially designed for you all for your preparation. Okay, and today we are going to start with your eigenvalues and eigenvectors. We have already seen ranks, system of equation, and then tomorrow we will have a complete wholesome practice of your linear algebra. Okay, and there's another announcement regarding the class schedule. So since every day at 12 p.m. we meet here at Lead Gate channel for your preparation, and we are here covering engineering mathematics. Similarly, I am also taking engineering mathematics on your live classes. So this my class schedule there is from 2:30. So from 2:30 I have those special classes for you. So there I have covered almost all the topics and a few are remaining. Like today we have for complex integration, complex analysis part 2. Okay, so in which we are going to study about complex integration today. So complex integration right from the beginning will be covered today. Then that's about today. And then from tomorrow onwards at 2:30 we'll also have mathematics portion, along with we are going to start with your aptitude. Okay, so from tomorrow we are going to start your aptitude syllabus. In aptitude we will start with your basic general mathematics in aptitude, general math, and then after this we will move on with your aptitude portion of arithmetic. Okay, and this complete which aptitude I have planned is basically focused on your GATE. So 15 days I'm going to cover all the aptitude part for you. So general mathematics, arithmetic, and as well as some English portion we are going to see, which is very important for your GATE preparation. Okay, so within 15 days we can just finish this and you won't even need a revision for any of this. You can practice at the same time in the classes, because as you know, if you have attended any of the classes, you must be knowing by now that I always start with the basic and then we always practice the questions related to your GATE and ES exam. So definitely you do not need to worry about it. In 15 days we'll cover it all. So that was my class schedule. So today at 2:30 you can join the class for complex integration and complex analysis part 2. Okay, so integration is starting today. So even if you do not know anything, you can still study integration. You can just have an overview of all the topic. Okay. Okay, so that was about it. So let's move on and start your preparation of eigenvalues and eigenvectors. Okay, so basically, till now you have seen that you solve your system of equation using the rank method. Find out whether a system is consistent, inconsistent, or what type of solution does it have. Okay, so that was one part of your linear algebra, which was very important. But this is another part which is quite different from your from your system of equation. This portion of eigenvalues and eigenvectors is asked mostly in all the branches and it holds the maximum weightage in your exam. ठीक है, तो सबसे ज़्यादा इसी का weightage रहता है और यही सबसे ज़्यादा important part भी है eigenvalues, eigenvectors and Cayley-Hamilton theorem. If you will see the previous year question papers, you will realize that majorly these questions have been asked from eigenvalues, vectors, rank and system. Okay, तो यही आपका major topic है. So we'll start with your eigenvalues and eigenvectors. Okay, so what do you understand with eigenvalues and eigenvectors? Basically, for matrices, we can determine some certain set of values and vectors जिनका use करके we can determine the properties of your matrix. Okay, and it is used in a lot of fields, like even in civil, in electrical, in every field, in mechanical. So whenever you are designing something and you want to analyze the properties, so you use these eigenvalues and eigenvectors for the same. ठीक है? The basic definition of eigenvalues and eigenvectors is for a matrix A such that it satisfies the condition Ax is equals to lambda x. Okay, when a matrix A satisfies this condition where x is a non-zero vector and lambda is a scalar quantity. Okay, so when a matrix satisfies this condition, then at that time you have x called as your characteristic vector or eigenvector, corresponding to your value lambda. ठीक है, corresponding to lambda, which is your eigenvalue. बेसिकली आपके जो भी मैट्रिक्स है, suppose it is a 3 cross 3 matrix, in that case you will have 3 lambda values and corresponding to each lambda means corresponding to each eigenvalue you will have one eigenvector. ठीक है, तो हर एक आइगन वैल्यू के लिए एक आइगन वेक्टर आएगा आपके पास, तो जितनी भी आइगन वैल्यूज होंगी उतने ही आइगन वेक्टर्स करस्पॉन्डिंग आपके पास होंगे. ओके, बाय डेफिनेशन बेसिकली आप इसको इस तरह से लिख सकते हो, a माइनस लैम्डा आई इंटू वेक्टर x इज इक्वल्स टू योर नल वेक्टर. ठीक है, तो यहाँ पे जो a माइनस लैम्डा आई आपका होता है दैट इज कॉल्ड एज a माइनस लैम्डा आई is equals to 0. This is called as your characteristic equation of matrix A. Characteristic equation of matrix A. Basically, क्योंकि आप इस अगर equation में देखो, you know that vector x is a non-zero vector, and since this is a non-zero vector, definitely a minus lambda I should be 0, and this a minus lambda I is the characteristic equation of your matrix A. The roots of this equation, okay, so when you find the roots of this equation will give you the eigen values. Okay, and using the eigen values you can find the eigenvector. We will see how. Now another thing to note here is when you solve this a minus lambda I, determinant is equals to 0. Okay, so when you put this equals to 0, you will get a polynomial equation. You will get a polynomial equation in lambda. ठीक है, तो the degree of this polynomial equation, degree will be equal to the order of your matrix. ठीक है, अगर आपका 3 क्रॉस 3 मैट्रिक्स है तो डिग्री ऑफ योर पॉलिनोमियल इक्वेशन विल बी 3, दैट इज ऑर्डर ऑफ योर मैट्रिक्स. इसीलिए इसके जो रूट्स आएंगे दे आर ऑल्सो इक्वल टू द ऑर्डर ऑफ योर मैट्रिक्स, बिकॉज जितनी डिग्री होती है उतने ही रूट्स होते हैं, राइट. सो इफ योर डिग्री इज 3 देन यू हैव 3 रूट्स. इफ योर डिग्री इज 2 दैट मीन्स यू हैव 2 रूट्स फॉर योर आइगन वेक्टर. नाउ जस्ट हैव अ लुक. सपोज यू हैव अ मैट्रिक्स P. लेट अस टेक अ मैट्रिक्स. ठीक है, तो फॉर फाइंडिंग द आइगन वैल्यूज as I told you, a minus lambda I determinant is kept is equals to 0 and you find the root. Okay, so this is the conventional way, but we are not going to use this conventional way. हमारे पास कुछ generalized property इधर से derive होती है जिसका use करके we can directly find out the values of your eigen values and eigen vector. Basically this for smaller matrix it is easy, right, but जब बड़ी matrix होती है तो we are generally bound to use that properties. So we will look at those properties, but you should also know कि हम characteristic equation लिखते कैसे हैं. ठीक है, because characteristic equation is important to write when we are trying to find your Cayley-Hamilton theorem. ठीक है, तो we will just write this a minus lambda I. So you will have 4 minus lambda 5 2 minus 5 minus lambda. This will be your P minus lambda I determinant. So now when you equate it to 0, what you get here, क्या मिलेगा आपको, 4 minus lambda into 5 plus lambda is equals to 0. So now when you solve it, you will get here lambda square plus lambda minus 30 is equals to 0. ठीक है, ये आ गया आपके पास. तो अब आप देखो यहाँ पे ये आपकी क्वाड्रेटिक इक्वेशन बनी है, जैसे कि आपको बोला था डिग्री विल बी इक्वल टू द ऑर्डर ऑफ द मैट्रिक्स. तो आपको पता चल जाएगा यहाँ पे 2 ही रूट्स होने हैं. ठीक है, तो कितने आइगन वैल्यूज आने हैं, जितना ऑर्डर है आपके मैट्रिक्स का. तो यहाँ पे 2 ऑर्डर है तो 2 आइगन वैल्यूज आएंगे. नाउ इफ यू फाइंड द रूट यू कैन राइट इट एज दिस. So basically lambda is equals to 5, lambda is equals to minus 6 is the. तो हमको यहाँ पे characteristic equation लिखना आना चाहिए because we are going to use this in Cayley-Hamilton. Okay, for finding the eigenvalues and eigenvectors, we have some certain properties which we are going to discuss right now, just so you can directly find the eigenvalues. Okay, so let's see how we are going to write the eigenvectors. ठीक है, तो आपने आइगन वैल्यूज निकाल लिए. सो लैम्डा इज इक्वल्स टू 5 इज वन आइगन वैल्यू एंड लैम्डा इज इक्वल्स टू माइनस 6 इज अनदर आइगन वैल्यू. तो हाउ आर यू गोइंग टू राइट द आइगन वेक्टर. ठीक है, तो लैम्डा इक्वल्स टू 5 के लिए एक आइगन वेक्टर आएगा लैम्डा इक्वल्स टू -6 के लिए दूसरा आइगन वेक्टर आएगा। तो कैसे लिखोगे आप आइगन वेक्टर? जो बेसिक आपकी इक्वेशन है, द बेसिक इक्वेशन a माइनस लैम्डा आई इंटू वेक्टर x इज इक्वल्स टू 0, ये आप यूज करोगे फॉर राइटिंग द आइगन वेक्टर। ठीक है, तो दिस x is the eigenvector corresponding to this lambda. Okay, so let us see how we are writing. तो आप a minus lambda I लिखो यहाँ पे. So instead of lambda, you just put the value of lambda, which is 5 here in this case, into your vector x. तो आपके यहाँ पे 2 क्रॉस 2 मैट्रिक्स है, तो वेक्टर में भी दो ही वेरिएबल्स होंगे, x1 x2 is equals to your null matrix. So now when you write, so you will see here you are getting -1 and 5, and here in the second row you are getting 2 and -10. So when you write it, you will get -x1 plus 5x2 is equals to 0. Okay, दोनों ही इक्वेशन आपको ऐसे मिल रही हैं. So you will see that 5x2 is equals to x1 is your relationship you are getting. Okay. So now here, if suppose I'm taking x2 is equals to t, okay, that means I can write x1 is equals to 5t. So I am writing the vector x for lambda equals to 5 will be written as x1 x2. So x1 की जगह मैंने x2 की जगह I have taken t, so x1 I have got 5t, right? So you see t, if you take common, this is the vector you are getting. Okay, so you look at this vector t into 5 1. Basically जब भी हम आइगन वेक्टर निकालते हैं, we are basically concerned with the proportion. ठीक है, या रेशियो से हमको मतलब होता है, because this t which you see, if I multiply any scalar value, suppose I multiply 10, so this vector will become 50 10. ठीक है, so it does not matter, but it is the eigenvector corresponding to lambda equals to 5, and that's why we are always concerned with the proportion, because t can take any value, क्योंकि एक वो क्या है, एक जनरल आपका वेरिएबल है which will take any scalar. Okay, it can take a positive or a negative value. Now for lambda equals to -6 भी आप इसी तरह से लिख सकते हो. You can write it as, so we will write 4 minus -6, it will become 10. Then here it's 5, 2 and 1. Okay, so this is what you have got for lambda equals to -6 is equals to your null vector. So आप यहाँ से लिखोगे तो you will get 2x1 is plus x2 is equals to 0. तो आपको यहाँ से मिल रहा है x2 is equals to -2x1. So again if I take x1 is equals to some suppose k, I can write x2 is equals to -2k. तो अब आपका जो वेक्टर आ गया है x1 x2 corresponding to lambda equals to -6, that you have got as lambda and minus. So now you will see कि हम वापस से we are concerned with the ratio or the proportion in which the vector is. ठीक है, तो हमेशा हमें proportion से ही मतलब होगा. We are concerned with the basic vector. ठीक है, क्योंकि k can take any value. Okay, is that clear? Okay, let us now look upon the important properties of eigenvalues and eigenvectors. Okay, so let's have a quick note of all those important properties. Basically सबसे important कुछ properties हैं, 2-3 that I'll tell you, but do remember that if you are writing the eigenvalues of a matrix A and the eigenvalues of matrix A transpose, they will be equal. Okay, so this is the basic thing. तो अगर A और A transpose का आपसे eigenvalues and eigenvectors पूछा जाए तो दोनों same होंगे. Similarly, आपके जो maximum number of distinct eigenvalues हैं, that is equal to the size of A. That I have already told, but just have a note, maximum number of distinct eigenvalues. Similarly, ये वाली जो property है, this is very important. That is, the sum of all the eigenvalues of matrix A is equals to the trace of A. ये वाली प्रॉपर्टी हम यूज करेंगे सबसे ज्यादा for finding out the eigenvalues of a matrix. And this another one, second one, that is the product of your eigenvalues for any matrix will be equal to the determinant of that matrix. ठीक है, तो ये जो दो प्रॉपर्टीज है आपकी, दे आर वेरी इंपॉर्टेंट इन डिटरमाइनिंग द आइगन वैल्यूज. ठीक है, अब आप यहाँ पे सुनो, if the product is equals to the determinant, if in case your matrix A is a singular matrix. Singular matrix का मतलब, what do you understand with singular matrix? That the determinant is 0. Okay, so that means the determinant is 0, that means the product of eigenvalues is 0. Then in that case you can say that one of the eigenvalues, at least one of the eigenvalues is 0. Okay, it can happen that more than one are also 0, but at least एक तो ऐसी होगी जो 0 होगी. Then this property, some certain properties are related, we'll see those. Then the next property is for an upper triangular and lower triangular, upper triangular and lower आपके जो triangular matrix होती है, for that case your eigenvalues are equal to your diagonal elements. Directly आप यहाँ पे you can write the eigenvalues equals to your diagonal elements. ठीक है, यहाँ पे आपको ज्यादा कुछ solve भी नहीं करना पड़ेगा because you will directly come to know the eigenvalues. Then yeah, if you have a matrix like this, suppose, okay, in which all the elements are 1, in that case the eigenvalue of such a matrix will be equals to, only one value will be non-zero, that is equals to the order of the matrix. Okay, तो इसका order कितना है, 4 है ना, 4 क्रॉस 4, तो एक वैल्यू होगी इसके आइगन वैल्यू, दैट इज 4, एंड रिमेनिंग ऑल अदर आइगन वैल्यूज विल बी 0. ठीक है, तो 4 आइगन वैल्यूज होती है मैक्सिमम, तो उसमें से सिर्फ एक नॉन जीरो है, दैट इज 4, एंड द अदर 3 आइगन वैल्यूज आर 0. ठीक है, तो अगर 3 क्रॉस 3 एक ऐसा डिटर्मिनेंट या मैट्रिक्स होता है आपके पास जिसका हर एलिमेंट 1 है, इन दैट केस आप क्या बोलते हैं, आइगन वैल्यू जो एक नॉन जीरो आइगन वैल्यू है, दैट विल बी 3 एंड द अदर 2 आइगन वैल्यूज विल बी 0. ओके, इज दैट क्लियर? So this is a direct property which can be used. And then there's another property that if you have a Hermitian matrix, ठीक है, या फिर symmetric matrix, ठीक है, for Hermitian or symmetric matrix, in that case you will have the eigenvalues as real numbers. Eigenvalues are real numbers. Okay, I have only said that the eigenvalues are real numbers. I have not said that they will be positive, negative or anything. मैंने बोला कि वो सिर्फ real number होंगे. Real होंगे मतलब complex part नहीं होगा. That's it. Okay, there was a question in which they have asked that if the eigenvalues will be real and positive. Okay, so that is not true. It can be negative as well. Then for a skew Hermitian, or I could say a skew symmetric matrix, skew Hermitian and skew symmetric matrix, the eigenvalues are purely imaginary or 0. Purely imaginary और 0. Okay, तो दो ही चीजें होती है for a skew Hermitian or a skew symmetric matrix. Either the eigenvalues are purely imaginary or they will be 0. There's no another case for this. And for your unitary and your orthogonal matrix eigenvalues of unitary and orthogonal matrix the absolute value of your eigenvalues, absolute value is 1. Absolute value is 1. That means if you take the value of that eigenvalue then it will be 1. तो 1 कैसे हो सकता है? +1 हो सकता है, -1 हो सकता है, +i -i, that will also be your eigenvalue. That can be because उनकी absolute value is 1. Okay, if you just look at the value ignoring the sign. Okay, these are some properties. Then there are some related properties for your eigen values and vectors for a matrix. Suppose you have a matrix A, ठीक है, जिसकी वैल्यूज है λ1, λ2, λ3 एंड सो ऑन. ओके, लेट अस कंसीडर एन एग्जांपल आल्सो. जैसे जो भी आपने मैट्रिक्स ली थी 5 4 5 2 -5, अभी आपको जो मैट्रिक्स सॉल्व करके बताई थी जिसमें इसकी वैल्यूज थी λ1 इज इक्वल्स टू 5, λ2 इज इक्वल्स टू -6. ठीक है, सो नाउ इफ यू वांट टू फाइंड द आइगन वैल्यू ऑफ सम मैट्रिक्स सपोज KA, ठीक है, तो उसके आप आइगन वैल्यूज डायरेक्टली k λ1, k λ2, k λ3 and so on, you can just write directly, multiply it with a scalar where k is a scalar. So suppose this is your matrix P. If I have to find the value, eigen value of 3p, so the eigen value of 3p I can write that they will be equal to 15 and -80. Okay, directly you can just write it that way. Similarly, अगर आपको आइगन वैल्यूज निकालनी है A इनवर्स की, तो आप डायरेक्टली लिख सकते हो इट विल बी 1/λ1, 1/λ2 एंड सो ऑन, 1/λ3. ओके, तो क्योंकि इनवर्स इज जस्ट द रिवर्सल ऑफ योर मैट्रिक्स, तो आइगन वैल्यूज भी 1/, में हो जाती है. सो इफ आई हैव टू राइट द आइगन वैल्यूज ऑफ P इनवर्स, आई कैन से इट विल बी 1/5 एंड -1/6. ठीक है, इस तरह से आपका डायरेक्टली आप लिख सकते हो. सिमिलरली अगर आपको सपोज लिखना है आइगन वैल्यूज ऑफ a टू द पावर सम नंबर, ओके, a टू द पावर n का आइगन वैल्यूज लिखना है, देन इन दैट केस आप वापस से डायरेक्टली λ1 पावर n, λ2 पावर n and so on, you can just write it. Okay, suppose example, if you have to write the eigen value for this matrix suppose p square, इसका आइगन वैल्यूज अगर आपको लिखने होते तो आप डायरेक्टली लिख देते इट विल बी 5 स्क्वायर एंड -6 स्क्वायर. तो कितना हो जाता 25 एंड 36. ठीक है, तो आपको पूरे नंबर का स्क्वायर लेना है, डोंट मिस द साइन, एल्जेब्रिक नंबर्स चाहिए. ठीक है, ओके, एंड इफ यू हैव टू फाइंड सपोज दो मैट्रिसेस हैं आपके पास एंड देन यू हैव टू फाइंड something like this, ka to the power n plus plus b to the power some other value suppose m. ठीक है, तो a के लैम्डा आइगन वैल्यूज आर λ1, λ2, λ3. सपोज इसके आइगन वैल्यूज हैं λ1, λ2, λ3 एंड सो ऑन, एंड इसके आइगन वैल्यूज लेट अस से k1, k2, k3 एंड सो ऑन. ओके, तो इन दैट केस आप कैसे लिख सकते हो? यू कैन डायरेक्टली राइट, यू विल राइट इट एज a λ1 पावर n, पहला आइगन वैल्यू क्या होगा a λ1 पावर n प्लस b k1 पावर m, पहला आइगन वेक्टर. then you can write second one as a λ2 power n plus b λ2 power m. okay, so correspondingly आप सारे लिख सकते हो, it's not a problem. is that clear? तो suppose आपको यहीं पे I'll say you have to find the eigen value of 3p cube plus p square. okay, like that. तो आप कैसे लिखोगे? So you have one eigenvalue of p as 5 and other one is -6. So you will write it as 3 into p क्यूब दैट इज एक 5 के लिए जब लिखोगे तो 5 क्यूब प्लस p स्क्वायर दैट इज 5 स्क्वायर and the other one will be 3 into minus 6 cube plus minus 6 square. ठीक है, so this is directly how you can write for your matrix. And one last one in this similar way, if you have to write the eigenvalue of adjoint of A, ठीक है, तो adjoint of A की eigen values जो होती है that is equals to determinant of A upon lambda 1, determinant A upon lambda 2 and so on. ओके, सो दिस इज वेरी हेल्पफुल. अगर आप सिंपली एक मैट्रिक्स का निकाल लेते हो तो आपको बाकी किसी भी मैट्रिक्स के लिए चिंता नहीं करनी पड़ेगी. यू कैन डायरेक्टली राइट. तो डू रिमेंबर दीज इंपॉर्टेंट प्रॉपर्टीज क्योंकि ये बहुत काम आने वाली हैं आगे हमारे लिए. सो विल सी अ फ्यू क्वेश्चंस एज वेल कि कैसे क्वेश्चंस आपसे पूछे जाते हैं इन योर गेट एंड ईएस एग्जाम. लेट अस सी. ओके, सपोज यू हैव अ क्वेश्चन. This is the matrix and you have to write the eigenvalues and eigenvectors, eigenvalue and eigenvector for this. So आप just solve the two and find out. ठीक है, तो आइगन वैल्यू निकालने के लिए अभी हम कैरेक्टरिस्टिक इक्वेशन वगैरह कुछ भी नहीं लिखेंगे. डायरेक्टली वी विल find the eigenvalues using the property. ठीक है, तो the first most important property which I have already told you is that the sum of eigenvalues, ठीक है, lambda 1 lambda 2 अगर eigenvalues हैं तो sum of that eigenvalues equals to the trace. Trace is the sum of diagonal elements. So it will be minus 4 plus 3 that is minus 1 and the product is equals to the determinant. So the determinant is minus 12 minus 6 that's minus minus 8 that's minus 20. So these are the two. So now you have to solve. So you'll see that the sum is minus 1 and the product is minus 20. तो कहीं अगर आपको directly नहीं समझ आता है कि how we do it, so just listen here. You split this product into two parts such that you check कि sum उनका minus 1 हो. So कैसे आप कर सकते हो, या तो 20 into minus 1 होगा या फिर 1 into minus 20 होगा, or it can be your 4 into minus 5 or minus 4 into 5. Okay, these are the ways possible in which it will be minus 20. The product is minus 20. So now check in which the sum is minus 1. So if you see, the only possible way here with you is this. So you will see that you can write lambda 1 is 4 and lambda 2 is minus 5. ठीक है, आपको पता लग गया lambda की value directly. Now write the eigenvectors. ठीक है, so I am writing the eigenvector for lambda equals to 4. So I directly write the matrix A minus lambda I. So this is minus 4 minus 4, it will be minus 8, it will be 2, 4, 3 minus 4 will be minus 1 into your matrix X is equals to your null matrix. ठीक है, तो अब आप यहाँ पे देखो, when you write the two equations you are getting, so you will see the first equation is giving you minus 8x1 plus 2x2 is equals to 0 and उसको आप simplify करते हो तो वो आ रहा है 4x1 minus x2 is equals to 0. दोनों एक ही equation आपको दे रहे हैं. So from here you will get another relation. this relation. ठीक है, तो आपको एक ही relation मिल रहा है दोनों equation से, पहले रो से भी second रो से भी. So what you get, that your proportion of your ratios is, if I take x1 is equals to t, then x2 will be equals to 4t. So I can write my eigen vector here as t and 4t. तो basically आपको जैसे मैंने बोला, we are concerned with the proportion. तो eigen vector आप इसका क्या लिखोगे, eigen vector for lambda equals to 4 will be 1 and 4. Because t is a scalar multiple, कुछ भी हो सकता है, it does not matter. तो आपको simplest proportional form में आंसर देना है. Similarly, अगर अब आपको eigen vector of lambda equals to minus 5 लिखना है तो how you are going to write? Just quickly write it. तो a माइनस लैम्डा आई आप करोगे तो -4 माइनस -5 दैट विल बी +5, so you'll get 1. 3 minus -5, so it will be 8, and this x1 x2 is equals to your null vector. ठीक है, फिर से देखोगे जब आप इक्वेशन लिख रहे हो तो यू आर गेटिंग x1 प्लस 2x2 इज इक्वल्स टू 0. दोनों इक्वेशन एक जैसी ही मिल रही है. ओके, अगेन आई कैन टेक x2 सम k, then x1 will be minus 2k. So I can write my eigen vector here as k, I am taking common 1 minus 2. तो लैम्डा इक्वल्स टू -5 के करस्पॉन्डिंग आइगन वेक्टर कितना आ रहा है? 1 minus 2. दैट्स इट. ठीक है, तो बहुत इजी है आइगन वेक्टर लिखना भी और आइगन वैल्यूज फाइंड करना भी. Okay, so when you just do it 3-4 times with some matrices and you will come to know it's very easy. The only thing is you have to write it in some proportion. ठीक है, we will see some more example जिसमें you will come to know that how the eigen values and vectors are changing and how the questions are formed. Okay, so is there any problem in writing eigen vectors? Because most of the students face this problem in writing eigen vectors. So just tell me if you have any problem, or else we will move forward with another question. Okay, see, I think there is no problem till now, so I think we can move forward. Okay. So let's take another example of your GATE question. There was a question in which they asked an eigenvector of P is a matrix which is given a 3 cross 3 matrix 1 1 0 0 2 2 0 0 3. Okay, so you have to tell me the eigen vector of this matrix P. So just find it out. सबसे पहले तो आप eigen values बता दो, which you can directly tell if you have studied the properties properly. तो बेसिकली अगर आप देखो, you can directly see that this matrix is a upper triangular matrix. ठीक है, तो upper triangular matrix है, तो in an upper triangular lower triangular you can directly say that the eigen values are equal to your diagonal elements. ये प्रॉपर्टी आपने देखी थी अभी. तो आपके जो आइगन वैल्यूज यहाँ पे क्या क्या हो गई? 1 2 एंड 3. डायरेक्टली आप बोल सकते हो. ठीक है, कुछ भी ट्रेस निकालना, डिटर्मिनेंट कुछ भी नहीं करना है. डायरेक्टली यू कैन से दैट योर आइगन वैल्यूज आर डायगोनल एलिमेंट्स. नाउ राइट द आइगन वेक्टर. सपोज फॉर लैम्डा इक्वल्स टू 1 यू आर राइटिंग द आइगन वेक्टर. सो हाउ यू आर गोइंग टू राइट द आइगन वेक्टर्स? क्विकली वी कैन राइट इट. सो 1 minus 1 will be 0. This is what you are getting. अब आपका आइगन वेक्टर कितना होगा? इट विल बी अ 3 क्रॉस 1 मैट्रिक्स. सही है, बिकॉज इट इज अ 3 क्रॉस 3 डिटर्मिनेंट. ठीक है, सो नाउ इफ यू सी, यू डू नॉट हैव एनी नॉन जीरो वैल्यू इन द फर्स्ट कॉलम. तो इसका मतलब x1 के लिए यू कैन नॉट से एनीथिंग, बट फॉर इफ यू सी इन द फर्स्ट रो सेकेंड कॉलम you are getting here x2 is equals to 0, and in the third column, last row, if you see, you get x3 is equals to 0. So that means x2 and x3 are 0, but x1 you cannot say. So x1 can take any value. ठीक है, x1 can take any value. How did you say that? समझ आ रहा है? कॉलम, फर्स्ट कॉलम में कोई भी नॉन जीरो एलिमेंट है ही नहीं, तो आप x1 के ऊपर कुछ कमेंट नहीं कर सकते. So now when you write the eigen vector here, x1, x2, x3, so x1 can take any value, suppose k, x2 is 0, x3 is 0, तो अब आपका eigen vector क्या हो गया? k 1 0 0. ओके, सिमिलरली लैम्डा इक्वल्स टू 2 के लिए आप लिखो, तो लैम्डा इक्वल्स टू 2 के लिए आप लिखोगे तो ये आएगा आपका मैट्रिक्स, एंड दिस विल बी योर वेक्टर. तो अब यहां से देखो आप, तो थर्ड कॉलम से आपको दिख रहा है दैट x3 विल बी x3 will be 0, then in the first row you can write an equation x1 plus minus x1 plus x2 is equals to 0. So you get x1 is equals to x2. So now you write the eigenvector. So if I take x1 as t, then x2 is also t, and x3 we already know is 0. तो ये आपके आ गए आइगन वेक्टर. ठीक है, लैम्डा इक्वल्स टू 2 के लिए. कोई डाउट है तो बताओ. Similarly, you can write for lambda equals to 3 as well. Okay, now let us look into some good question of your GATE. There is a question. It is given the eigenvalue of matrix are 2 and 1 and the eigenvectors corresponding to this matrix are given to you. Now you have to tell the value of a plus b is equals to what. ठीक है, तो इज द क्वेश्चन क्लियर. उन्होंने डायरेक्टली बता दिया है. आइगन वैल्यूज नहीं भी बताते तो यू कैन डायरेक्टली फाइंड आउट. इट इज एन अपर ट्रायंगुलर मैट्रिक्स. इन अपर ट्रायंगुलर मैट्रिक्स द डायगोनल एलिमेंट्स आर द आइगन वैल्यूज. अब आपको आइगन वैल्यूज पता है. दे हैव गिवन आइगन वेक्टर्स इन द फॉर्म a एंड b. यू हैव टू फाइंड द वैल्यू ऑफ a प्लस b. सो जस्ट फाइंड द वैल्यू ऑफ a प्लस b. a प्लस बी निकालने के लिए क्या करना पड़ेगा आपको. यू हैव टू राइट द आइगन वेक्टर्स फर्स्ट. तो आइगन वेक्टर्स आप लिखो. सो इफ आई राइट द आइगन वेक्टर करस्पॉन्डिंग टू लैम्डा इक्वल्स टू 1, सो आई राइट इट. लैम्डा इक्वल्स टू 1 रखेंगे तो ये आपका मैट्रिक्स होगा एंड दिस इज योर आइगन वेक्टर. So now you see here फर्स्ट कॉलम के बारे में आप कुछ नहीं बोल सकते हो. फर्स्ट कॉलम करस्पॉन्ड्स टू x1. So x1 can take any value. Okay. And x2 you are getting as 0. So I can write directly the eigenvector as sub k times, okay, some k times 1, 0. ठीक है, तो eigenvector मैंने आपको पहले भी बोला है, we are concerned with the proportion. So this is one of the eigenvector. So another eigenvector which is lambda equals to 2 से correspond करोगे आप, तो it will be -1, 2, 0, 0. Again here you have x1, x2. तो अब आप देखो यहाँ पे आपकी इक्वेशन आ रही है -x1 plus 2x2 is equals to 0, or I can say that x1 is equals to 2x2. So I will write that directly. If I take x1 is equals to some t, then x2 I can write as t by 2. So if I write here t and this will be t by 2, तो आपका जो वेक्टर आ रहा है प्रपोर्शन से मतलब है, तो t आप कॉमन ले लो 1/1 by 2. अब आप कंपेयर करो with the given eigenvectors. These are the given vectors. So on comparing it, I'm putting it equal to 1 by a and 1 by b. So in that case I get a is 0, b is 1 by 2 and a plus b I can directly write it as 1 by 2. ठीक है, तो न्यूमेरिकल आंसर टाइप क्वेश्चन था, वेरी इजी. क्या चाहिए था, बस सिर्फ आइगन वेक्टर ही तो लिखना था. देयर वाज नथिंग व्हिच यू डू नॉट नो और यू कैन नॉट डू. ओके, इट वाज वेरी इजी. Okay. Okay, another question similar to this type of question. Let us see. अब एक रिवर्स क्वेश्चन करते हैं. ओके, डायरेक्ट क्वेश्चन था ये, इसमें लैम्डा की वैल्यूज निकाल के वेक्टर लिखना था एंड दैट वाज इजी. But then let's see some reverse question in which they will give you the vector and they will ask you about the matrix. ठीक है, तो ऐसा उल्टा क्वेश्चन भी पूछेंगे. So let's see. a matrix is given, the eigenvalues of a matrix are -1 and -2. The corresponding eigenvectors भी आपको दे रखे हैं, that are 1 - 1 and 1 - 2. The matrix is okay, and multiple choice question है, तो गेट का ही क्वेश्चन है, तो ऑप्शंस भी हैं. So tell me how you're going to approach this question. For approaching such type of question, it's very easy basically. देखो क्या करना है, कुछ भी नहीं करना है. जो आपकी कैरेक्टरिस्टिक इक्वेशन आप लिखते थे ना, a minus lambda I is equals to, ये जो आपकी बेसिक ax is equals to lambda x, ये वाली इक्वेशन आपके बहुत काम आने वाली है इस तरह के क्वेश्चन में. ठीक है, तो सपोज दोनों तरीके से कर सकते हो. इधर यू satisfy the option और यू जस्ट राइट अ मैट्रिक्स, क्योंकि 2 क्रॉस 2 मैट्रिक्स है, दो ही आइगन वैल्यूज है, तो 2 क्रॉस 2 मैट्रिक्स होगी. तो लेट मी सपोज दिस इज द मैट्रिक्स एंड आई नो दो आइगन वेक्टर्स, तो वन इज 1 - 1 जिसके करस्पॉन्डिंग आइगन वैल्यू है -1 एंड द वेक्टर इज 1 - 1. ठीक है, एंड द अदर आइगन वैल्यू इज -2 एंड द करस्पॉन्डिंग वेक्टर इज 1 - 2 -2 1 - 2. ठीक है, तो अब आपके पास देखो दो तरह से आपके पास इक्वेशन आ जाएगी एंड यू कैन जस्ट सॉल्व इट. सो एनी एलिमेंट यू जस्ट टेक एंड सॉल्व. तो ऑप्शंस के हिसाब से भी आप थोड़ा एलिमिनेट कर सकते हो. ऑप्शन सी, जस्ट चेक योर आंसर आशुतोष. आई थिंक यू मस्ट हैव मेड सम कैलकुलेशन मिस्टेक. तो लेट अस सी. आप डायरेक्टली थोड़ा सा ऑप्शन के हिसाब से, इफ यू सी द third, the C and D element of all the matrices are somewhat different. So I will go with the C and D first. So C और D element पहले निकालने के लिए I'll multiply the second row with the vector. So I'll get C minus D is equals to, here I'll see कितना आ रहा है +1. and इधर से भी एक इक्वेशन लिखूंगी, C minus 2D is equals to 4 आ रहा है. ठीक है, so from here when you subtract both of these matrices, these two equations, from here you get D is equals to -3. ठीक है, subtract करने पे D -3 आ रहा है and C आपका आ रहा है -2. ओके, तो आप देखो एक ही ऑप्शन है in which C and D are -2 -3. so you got your answer. सारे भी सॉल्व करने की जरूरत नहीं है. ओके, Ashutosh, I think you have made some calculation mistake. Check it, okay? Okay, so this was some another type, and there are a few more type. They will give you some eigenvectors similarly and ask you for the eigen value or the matrix. तो बहुत easy से question होते हैं, ज़्यादा tough नहीं होते हैं. We will see a few more question. It is a question from 2015. The question is, maximum value of A, you have to find the maximum value such that this matrix -3 0 -2 will have 3 linearly independent real eigenvectors. Okay, has 3 linearly independent so you have to find the value of A. Okay, I think the question is clear. No, it's very clear in the words itself. These are the options with you. 2015 का क्वेश्चन है. ओके, जस्ट फाइंड आउट. तो बेसिकली आपको जब वो बोल रहा है मैक्सिमम वैल्यू ऑफ ए सच दैट 3 लीनियरली इंडिपेंडेंट रियल आइगन वैल्यूज चाहिए. लीनियरली इंडिपेंडेंट रियल आइगन वैल्यूज का मतलब है दैट इट शुड नॉट हैव एनी जीरो वैल्यू, राइट. सो उसको जीरो वैल्यू नहीं होना चाहिए. तो दो तरीके से आप इसको फाइंड कर सकते हो. द थिंग इज यू यूज द प्रॉपर्टी और you write the characteristic equation and satisfy the condition. ठीक है, so let us see how you're going to find. So the property, one basic property which is that you write the characteristic equation and then solve it and find the value of a such that you do not have repeated roots. ठीक है, repeated roots नहीं आए. So repeated roots नहीं आने के लिए you should know that your discriminant should not be 0. एक तो ये है. Otherwise you just maximize that equation for a. Okay, so we will see. We are going to write the characteristic equation. So characteristic equation आप जब लिखोगे, so you will write it this way. This is your characteristic equation. How you are going to write? तो जल्दी से इसको लिख लेते हैं. So just solve it. You will get a cubic polynomial here. I can write it as 2a is equals to minus lambda cube so this is what you are getting here, right. आपको मैक्सिमाइज करना है a को such that you have independent values. तो मैक्सिमाइज करने के लिए I can directly differentiate it with respect to lambda because I have to find maximum with respect to your eigen values. So I am differentiating it with respect to lambda. So I'll get here. ठीक है, ये आपके पास आ रहा है. Now if you put it equals to 0, so you'll get the value of lambda. So put it equals to 0. So when you put equals to 0 and solve this quadratic and find the roots, so what are the roots you're going to get? Minus b plus minus root over b square minus 4ac. So this will be 44/3. It will be 132 upon 6. ठीक है, तो ये आपके roots आ गए. So your value will be either maximum for this or it will be minimum for one of it. ठीक है, तो एक पे maximum आएगा, एक पे minimum आएगा. For checking it again, या तो आप इसको डिफरेंशिएट करके डबल डिफरेंशिएशन से पता कर सकते हो. सो इफ आई डबल डिफरेंशिएट दिस, व्हाट आई एम गोइंग टू गेट? आई एम गोइंग टू गेट d square a by d lambda square which will come equal to 6 lambda plus 12. So for a value which is negative minus 1/3 and I'll see here I'll get a positive value. ठीक है, तो positive पे तो minimum when I take lambda is equals to -2 minus 1/√3, this value will be d square a by d lambda square will be. So for this I can say it is minimum. So it will be maximum for lambda equals to -2 plus 1/3. So आपकी put lambda equals to -2 plus 1/√3 and you will get the value of a here. ठीक है, तो इसमें आप ये वाली value put करो and get the value of a and find the answer. What are you telling आशुतोष? Previous question eigen value का product and multiplication property पे तो डी भी आ रहा है ना उससे आंसर. चेक द क्वेश्चन आशुतोष. in that previous question, okay, what was the question? In that previous question, when you see B option is also coming as your answer there itself, ठीक है? -1 -2 आपके आइगन वैल्यूज हैं. डिटर्मिनेंट इज नॉट 0, राइट? उसके अंदर भी दोनों ऑप्शन सेटिस्फाई हो रहे हैं, ठीक है? वो मैंने इरेज कर दिया है क्वेश्चन. जो आपके आइगन वैल्यूज थे वो -1 -2 थे. ऑप्शन डी के लिए आपकी जो मैट्रिक्स थी दैट वाज 0 1 -2 -3. ओके, तो उस केस में भी द प्रोडक्ट वाज कमिंग आउट इक्वल टू 2 एंड योर सम वाज कमिंग आउट एज -3. ओके, so just find out the value of a. Put lambda is equals to -2 plus 1 by √3 in this equation. So you will get the value of a as 1 by 3 √3. Can you do the calculation or you need me to do the calculation? I think you will be doing this pretty easily. ठीक है. इसके अलावा अगर आप कोई दूसरा इसमें मेथड ट्राई करना चाहते हो तो मैक्सिमाइज करने के लिए आपको डेरिवेटिव का ही यूज करना पड़ेगा, बिकॉज विदाउट डिफरेंशिएटिंग एंड फाइंडिंग आउट इट्स नॉट इजी टू प्रिडिक्ट वेदर द वैल्यू विल बी मैक्सिमम और नॉट. ठीक है, इसलिए हमने डिफरेंशिएट करके निकाला है. ओके, सो दिस इज वन गुड क्वेश्चन फॉर यू टू प्रैक्टिस. And there are many more questions regarding your eigenvalues and vectors, especially EC and electrical people. They have very nice quality of questions from GATE. Okay, now we have to study about Cayley-Hamilton theorem as well. Okay, so we'll study Cayley-Hamilton theorem. Till now, do you have any doubt? Tell me. I assume do not have any doubt, so we can move forward with your Cayley-Hamilton theorem. Cayley-Hamilton theorem बहुत easy theorem है. It is basically used to find the inverse and relationship between higher order of your matrix and its linear variant. ठीक है, relationship between higher order of matrix. बेसिकली मतलब आप एक इक्वेशन लिख सकते हो इसका यूज करके, सच दैट इवन इफ यू हैव टू फाइंड सपोज a to the power 12, तो वो आपको एक लीनियर रिलेशनशिप आ जाएगा, सम कोएफिशिएंट मल्टीप्लाइड विद योर मैट्रिक्स A प्लस सम कोएफिशिएंट मल्टीप्लाइड विद योर आइडेंटिटी मैट्रिक्स. तो वो एक इजी रिलेशनशिप यूजिंग Cayley-Hamilton theorem you can find it out. Also for finding inverse for larger order of your matrix, Cayley-Hamilton theorem is used. So what does Cayley-Hamilton theorem say? It says that every square matrix will definitely satisfy its own characteristic equation. Okay, satisfies its own characteristic equation. So if you have to find the polynomial in your matrix A, what you do, you write the characteristic equation. ठीक है, तो suppose एक general characteristic equation कुछ इस तरह से आपके पास आ रही है, a1 lambda 1 power n, a1 lambda to the power n, a2 lambda to the power n minus 1. ठीक है, तो एक polynomial equation है ये of power n. Because I have already told you, when you write this characteristic equation, it will form a polynomial of your degree equals to the degree or the order of your matrix. So in this, Cayley-Hamilton says that you can replace lambda with your matrix A and the constant an is replaced with an into matrix I. I is an identity matrix of order n. Okay, so you can write this after replacing, and this will result in Cayley-Hamilton equation. and that equation will be a relationship between higher degree or higher order of your matrix with its linear form. We will see how. Okay, so I'll take another basic example जो पहले भी एक बार मैंने लिया है and we have solved it for your eigenvalues and vectors. So suppose this is the matrix. We have already seen this matrix. So you write the characteristic equation for this matrix. Okay, so if you remember, I have written the characteristic equation for this matrix already. So you got your lambda square plus lambda minus 30 is equals to 0. Okay, so as per your Cayley-Hamilton, you can just write a square, substitute lambda with matrix A and the constant with constant multiplied with your identity matrix. So this is your Cayley-Hamilton equation. अब आप इस equation को use करके how you can find out the inverse. Let us see how you find the inverse. तो बहुत basic सा है. For finding the inverse, what you do, you keep the identity matrix on one side and all the other matrix with higher powers on the another side. ठीक है, तो left right में इसको separate करके I'm keeping my identity matrix on this side and the other matrices I'm putting on the other side. Okay, now when I multiply it with A inverse, दोनों साइड मल्टीप्लाई कर रहे हूँ A inverse से, so you will see here identity matrix into A inverse is A inverse, which is 1 upon 30. A inverse into A square, so you can write A inverse into A square as A inverse into A. So this will become equals to identity matrix, and identity matrix into A will give you A. So you have here A plus again A inverse into A will be identity matrix. Okay, so you can see कि आपका जो inverse है वो directly it has come out into a linear relationship. So A inverse is 1 upon 30 A plus I. So 2 cross 2 matrix के लिए तो बहुत आसान है, but for a higher order matrix this relationship proves out to be very useful क्योंकि उधर inverse निकालने के लिए बहुत ज़्यादा मेहनत करनी पड़ती है and here without any trouble you can directly find a relationship. ठीक है, so this equation is also a characteristic equation for your matrix, है ना, where your matrix A satisfies this relation. तो आपको ऐसे questions वो पूछते हैं that this matrix what is the equation satisfied with the matrix. Okay, there has been questions like this. I'll tell you, there was a question in this GATE examination 2018 where they have asked this matrix A is given and they have asked the equation that satisfies the relation. This satisfies the relation. So आपके options दे रखे थे उन्होंने, exponent of A is equals to 0 and A plus 3I plus 2A inverse is equals to. So as such there were some options given. So whenever you see some options like this, where your matrix is in some square, cube and all those terms, and it is with your identity matrix in some linear relationship, you can directly say that it is definitely going to use the Cayley-Hamilton theorem. ठीक है, तो कुछ भी नहीं करना है, directly you write the characteristic equation for your matrix. So you write the characteristic equation. So when I write the characteristic equation here, I can write it as I'll get the characteristic equation lambda square plus 3 lambda plus 2 is equals to 0. So now if I substitute it with A, so I'll get A square plus 3A plus 2I is equals to 0. ठीक है, तो ऐसा तो कोई direct relationship दिख नहीं रहा है. Either there is A inverse, exponent is never going to come here in this equation. So this option is not correct. This option is also not satisfied. So let us see if I can just include A inverse. So A inverse include करने के लिए I have already told you just keep identity matrix on one side and the other matrices on the other side. And look what you're going to get. Multiply it with A inverse. You will get 1 by 2 A plus 3I. Okay, so again I can write it as 2a inverse and putting it on the other side, a plus 3i plus 2a inverse is equals to. Okay, so now you can see your option, this second option is satisfied. Okay, so this is one type of question which is asked, what equation relationship is satisfied with this matrix or not. And there is another type of question here. ठीक है, इसी में एक और second part है. They ask you to find a to the power 9. What is the value of a to the power 9? And the options were also given in terms of a. They were given as 154a plus 155i, then 309 and so on. Okay, तो आपको बेसिक आइडिया इसमें समझ आना चाहिए how we are using your Cayley-Hamilton theorem. So how you are going to use the Cayley-Hamilton theorem here? तो इस तरह के क्वेश्चन के लिए for inverse you kept identity matrix on one side and the other matrices on the other side, and then you found the inverse relationship. But for this type what you have to do is you have to keep the highest order matrix on one side and then derive relationship with the other matrix. Okay, so we'll see how. So you got your characteristic equation as a square plus 3a 2i is equals to 0. So I'm writing it as a square is minus 3a plus 2i. So now if I square it, I'll get a power 4, which will be 9a square 4i 12a, right? So now I can again substitute a square as minus 3a and 2i. So you will get a power 4 relationship in terms of a. तो एक फिर से आपको a power 4 का relationship linearly in terms of a आ गया. This is what you have got. Then again if you square it, a power 8 आ जाएगा. Square करोगे तो so it will come out as 225. I square is I and 14, this will come out as equals to 4. Okay, there's some trouble, just wait a minute. Yeah. So yeah, we were solving this. (156) ओके, तो अब आपके पास फिर से एक इक्वेशन आ गई a8 की. आप a स्क्वायर को फिर से कन्वर्ट, इधर a स्क्वायर यू सब्स्टिट्यूट दिस हियर एंड यू गेट एन equation with a power 8 linearly dependent on a. Okay, so we'll see what we're going to get. So minus 225 okay, so you will get something here. Just try to solve it. And then you multiply a with this a power 8, so and substitute a square, so you will get here. Okay, is that clear how you are doing this? So C will be your answer. तो basically इस type के दो ही तरह के question बनते हैं Cayley-Hamilton में, that either you write the inverse by separating the matrices of identity matrix on one side and the other matrices on the other side, and similarly keeping the higher order matrix on one side and then squaring the terms to find the higher order. Square kar sakte ho, cube kar sakte ho, and then you can just substitute. Okay, so these are the type of questions you get here in Cayley-Hamilton theorem. Then there was another one basic good type of question. In that question, they have asked that if there is a 3 cross 3 square matrix, in that case, okay, there was given a 3 cross 3 matrix P such that P cube is equals to P. Okay, then you have to find the eigenvalues of P. It is given that this matrix is P cube is equals to P satisfies this relation. You have to tell me about the eigenvalues. तो ये एक reverse question हो गया. How you are going to solve this? Basically, अगर ऐसा कोई भी relationship है with higher powers of your matrix, then that means they must have definitely used the Cayley-Hamilton theorem. तो अगर Cayley-Hamilton theorem use किया है, that means instead of the value lambda, you have substituted the matrix. तो आप वापस से matrix की जगह lambda substitute कर सकते हो, right? So instead of p, you can substitute lambda. Because Cayley-Hamilton theorem का आप एक तरह से inverse कर रहे हो, reverse कर रहे हो. So you will have lambda into lambda square minus 1 is equals to 0. From here you will see that the value of lambda is 0 and the lambda value is plus 1 and minus 1. So these are the three eigen values you are getting. Okay, so if they ask you about anything regarding the eigen values, what is the sum, what is the product, you can just simply tell. So I think there's nothing much from Cayley-Hamilton theorem, and in eigenvalues, yes, they can ask a variety of questions. What all you need to do is just practice a lot, because practice is what makes your calculation faster and minimizes the error. So I want you to practice more questions based on this eigenvalues, vectors and Cayley-Hamilton. And that's why tomorrow we have a practice session of your linear algebra, जिसमें पूरा starting to end all the good questions which till now have been asked, especially for people of CSIT, GATE, ESE and electrical. They have very good set of questions in linear algebra. So we will see all those questions, because now they do not ask you simpler question. ठीक है, simple questions नहीं पूछते हैं in linear algebra. They'll ask you good questions. Previously they used to ask many basic questions, but now they have changed the whole concepts, and the basic remains the same, but the level of question have increased. So we'll practice all the good varieties, and we'll also see the potential types of question which can be asked in your GATE 2021 and also in ES 2021, and then we'll solve them with detailed explanation and all. So do try to attend the practice session for all the questions and good practice on your topic of linear algebra. Do not forget to share it with your people, with your friends and people, so that they can also get aware about the knowledge of all the content which is being here. And the content which is prepared, सारा content आपके requirement के हिसाब से ही prepare किया जाता है. So the more you share, it shows us that more you need the content, similar content. So if you need more such content, just try to share it as much as possible. And do not forget to attend my class at 2:30 on complex integration. Okay, so complex integration हम आज live class में cover करने वाले हैं, which is absolutely free class for you. What you have to do is, in the Unacademy learning app, in the live class section, you can search by my name, Arohi. Okay, in the live class section, search my name, and you will get my profile, where you can also get notifications for, if you follow me, you will get the notifications of the upcoming lectures. and also you will be able to see all the lectures which have already been covered, in which I have covered a lot of part of your engineering mathematics with questions. So if you want, you can watch it as well. आज complex integration करने वाला है 2:30, and for getting the access you can use this code ARO10, and also you can share this with your friends and colleagues so that they get to take the advantage as well. And other than this, if you have any queries, you can let me know and mail me the same by at my mail ID. This is the mail. You can just send me. And for the upcoming notifications as well, I do share it on the Telegram group. So do join our Telegram group on the Lead Gate channel and follow us so that you have the notifications for the upcoming classes. Okay, so that's all. Keep practicing, keep learning. We'll meet again tomorrow at the same time for your practice session. That's all for today. Thank you so much. Thanks for joining.